Okay, so from yesterday, you guys found some patterns. For my pattern 1, figure 1, how many tiles were there?
6.
Okay, some of you did 6 and some of you did 2, correct?
Yes.
And then the next was 18, 54, help me out, everyone, please. 162, 486, like that? What's the 6th term? 58. And then did you have the 13th term?
Yes. 3,188,600.
3,188,646.
88,646.
Okay, so that's the 13th one. Okay, for pattern 2 from everyone. What is, how many tiles are in figure 1? Okay, 2, 3, 4, 21. What about 6? 25, and then did you have the 13th one? 53, okay, good. What about pattern 3? How many tiles were in the first one? 80, then what? And then 10, 2.5, and I'm actually going to write 5 divided by 2 there, okay, because that is the factor that I'm multiplying by. It will be 2.5, and then 13 would be a really small decimal. 0.0195, which is 5 divided by 2 to the 6, 7, 8, 9, 10, 11, 12. Hold on. 6, 7, 8, 9, 10, 11, 12, 13. I think that is 2 to the 8th power, so this is 5 divided by 2 to the 8th power. So if you find 2 to the 8th and then 5 divided by that, it should be the same decimal that you have. Okay, and then finally for pattern 4, what was that one? 25, 19, and negative 47. Okay, that's what we got. Now, you're going to graph these. I'm going to give you 3 minutes to do all 4 of the graphs, so listen carefully. Listen, because you just said you didn't know how to graph, so I'm helping you. I have an x coordinate. I have a y coordinate. Now graph them. Okay? You have an x coordinate and a y coordinate and graph them. Okay, so we just went over these tables. And we had all of those values down. We even got the 13th value for now. So that was 1, 2. Here are 3 and 4. We just fixed those. On pattern 4, that should be a -5, not a -15. Okay. So make sure all your tables are correct. Okay. And this should be what your graphs look like. Okay. Mine are in a different order than yours. Mine go 1, 2, 3, 4. No. Yours go 1, 3, 2, 4. Correct? That's how I said. They should. So you didn't listen yesterday when I told you guys to read the tables. Correct? Okay. So if you drew lines through these points, please erase them. We do not want to connect these dots. That is something called discrete versus continuous. Okay. It's continuous if it has a line going through it, and we'll talk about this later. It's discrete because each of these points are separate and distinct. Because I had figure 1, I had figure 2, I had figure 3. Did I have a figure 1.5? Was one of my patterns figure 1.5? I'm asking you a question that can be answered by looking at your notes. Did I have a figure 1.5? No. So that means I can't draw a line that goes through there. So that means each point is just a point. Okay? Each point should be just a point. Did I talk to you guys yesterday about doubling the money in your bank account for interest, and then I talked about the car when it drives off the lot and it loses its value too. So that's going to be 2 of our graphs, not both of them, or not all 4 of them, 2 of the 4. Okay, I'm going to move on beyond this. Okay, because now these sequences, if I look at them, they can kind of go together because I'm going to draw a line through them. Do I want you to draw a line? No. Okay, if I draw a line, does it hit all the points? On pattern 2? Yeah. If I draw a line through pattern 4, does it hit all the points? Look up here. Yes. Do I want you to draw a line? No. I'm just drawing a line so that you can see the shape of it. Okay, do you understand on pattern 2 they all line up to make a line? And on pattern 4 they all line up to make a line? Okay. So what that means is these are called arithmetic sequences. Now this will need to go into your notebook. Okay. There's no room on this paper, so go into your notebook. Our arithmetic sequences, patterns 2 and 4 are similar because you are adding or subtracting a constant value to find the next term, okay? So our arithmetic sequences add or subtract a constant value. So arithmetic is add or subtract a constant value. Arithmetic, add or subtract a constant value. Add or subtract a constant value. Okay, so one last time. Arithmetic is add or subtract a constant value. Next, I have my patterns 1 and 3. So pattern 1, those numbers get kind of big pretty fast. So I'm actually going to put in another point, which would be somewhere up here. I'm going to say that's 54. Is that okay? Do you agree with that? Okay. If I tried to draw a line, does that go through all the points? No. Let me try pattern 3. Does that go through all the points? No. So what would I have to do to connect them? What do you think that would look like? A curved line, maybe? Okay. So I'm going to... And this would come back in this direction. Like this. And this line would be over here as a curved line that goes on in that direction. So on number 3, do you see how, or on pattern 3, do you see how it falls by half, and then by half, and then by half, and then by half? And you see how it gets really small? Will that number ever be 0? No. Will it get very close to 0? Yeah, because if I keep dividing 5 divided by a larger and a larger and a larger and a larger number, that's going to get very, very close to 0 to make it a very small number, but it will never be 0. Remember yesterday I talked about a car? Your car will likely never be worth $0. It might only be, worth a couple cents or parts, but it'll only be worth something, even if it's a very small thing. So that means we're going to 0. Does that make sense? That means this will be my asymptote. 0 is the line that I can't cross through, get close to, but never touch it. So that makes sense? Do you see how I have the same kind of shape, but one is growing, getting bigger, and the other one is decaying because it's getting smaller? Those are both of our exponential functions, and that's what I kind of talked about yesterday. Now, these aren't called arithmetic sequences. They have a different name, okay? These are called geometric sequences. So our geometric sequences are like patterns 1 and 3 because you are multiplying or dividing a constant value. So arithmetic was add and subtract. Geometric is multiply and divide. Okay? And we're multiplying and dividing or adding and subtracting by our pattern rule. Okay, so if I had each of these graphs, that's what they would look like. Is number 1 geometric or arithmetic? What did we decide it was? Pattern 1, was it geometric or arithmetic? Were they adding and subtracting or multiplying and dividing? Multiplying. So what is that? Geometric. 2, was that arithmetic or geometric? Arithmetic because I'm adding. Okay, what about 3? Geometric or arithmetic? Geometric because what was I doing? What was my pattern rule? Dividing. Okay. And number 4, is that arithmetic or geometric? Arithmetic because I'm subtracting. So if you look at 1 and 2, these are geometric versus arithmetic, but they're both growing because I'm adding or multiplying. 3 and 4, these are geometric and arithmetic, but they are both decaying because I'm dividing or subtracting. So they'll have the same kind of shape, or they'll go in the same direction, but you have to determine if it's arithmetic or if it's geometric. Does that make sense? Okay. Tonight on your homework, and I mean we have like plenty of time, we still got a lot to do, but tonight on your homework, some of the questions will ask you, they'll just say, what is the pattern rule, okay? Now, if you want to identify, is that arithmetic or geometric, that's good practice, because on Tuesday you will have to do that in your homework. And then you will also have to write the equation or the formula given that information, okay? So, these are our arithmetic sequences, okay? And we're going to talk about finding the equation. So, is this 13th term in pattern 4, is the 13th term negative 17?
No.
Is it? Wait, but I thought that the pattern rule was subtract 6, minus 6, minus 6, minus 6.
No.
And 11, negative 11 minus 6 is negative 17. Oh, okay, so that's for the 8th figure, and I asked for the 13th figure? And what did you guys tell me the 13th figure was again? Negative 47, okay? So negative 17 is the 8th figure. It's the next one in the sequence, but I'm looking to skip a few in the sequence, okay? So I'm going to help you. We're going to figure out the formula that we can do. So that way I don't have to keep subtracting every single time. So this is a formula for our arithmetic sequences. It says to find any nth term. What do you think nth term means? Nth term. What is the nth term? Would you say, Helene? What do you mean the variable? Are you saying the variable is n? Okay, the variable is n. If I said the first term, or the second term, or the third term, or the fourth term, or the fifth term, or the sixth term, that means I have n equals 1, n equals 2, n equals 3, n equals 4. The reason we say the nth term is when we don't know which term number we're talking about. So if I say, write a formula to find the nth term, that means it will work no matter what term you're looking for, okay? So this is a linear function. Remember the arithmetic, I was able to draw a line through those points, and it went through all of them. That means it's a linear function, okay? And in a line, what does m equal? What does m stand for in my line? What I'm graphing, remember? You know how to graph a line? Because I retaught you 2 weeks ago. Remember I did it all up on the board and we wrote down all the formulas and what everything means? Ooh, this is going to be rough because that is 8th grade, 9th grade math. Does anybody know what m is in a line? The slope, yes. Or the common difference, or our pattern rule. So on our slopes before, they might be plus 4, plus 4, plus 4, or minus 6, minus 6, minus 6, okay? In a line, what other value do we have? What other b, okay? And b is our initial value, our term 0, or our y-intercept, okay? So we have m is our pattern rule, which is our common difference, like how much do I have between each of the numbers. And b is my term 0, or my initial value. We can write a rule or equation for this. It's very similar to our linear function, which is y equals mx plus b. But instead of using x and y as my variables, now we're using n. So our explicit formula is f of n equals m times n plus b. It's the same thing. I just swapped out some different variables, okay? This arithmetic formula in words, the arithmetic formula in words, is f of n, so whichever term I'm looking for, is the slope times that term plus the initial term, or the initial value, okay? So slope times the figure number plus the initial value. Are going to go back to the last one that we had, and we are going to find the explicit formula for pattern 4, okay? So I know that that is not the 13th term. It is not negative 17. And I know my formula is f of n equals m times n plus b. Did I write that down correctly? Is that correct? Okay, in this case, what is my m value? What is my slope? What is my common difference? What is my pattern rule? What did I do on pattern 4? How do I get each of those numbers? I subtracted 6. Do you all agree with that? That's a minus 6. Hello? Are you awake? I know you're crashing. It's lunchtime on Friday before a 3-day weekend. It's just get through this. Okay. Now, B, remember, that was my initial value or my zero term. Does this table start with the zero term? No. What term does this table start with? Not 25. I'm looking at the figure numbers, the x values. This starts with 1. Is 1 the zero term? Is 1 0? No. 1 is 1. 1 is the first term. I need to find the zero term. And you guys just told me this was minus 6, minus 6, minus 6, minus 6, right? This is correct. Yes or no? Okay. So then how would I find my zero term? But the pattern is minus 6. Why would I add 6? Oh, because I'm going backwards. So something minus 6 gave me 25. So if I want to find it, I can add 6. And what is 25 plus 6? 31. So let's see if our zero term is 31. Let's plug it in. Okay. So then I have n plus. So that means f of n equals negative 6n plus 31. Is that an equation that I can use? Yeah, it is. My stylus would cooperate. I think I need a new one. Okay, negative 6n plus 31. Is that an equation that I can use? That's a good explicit formula. Okay. Let's choose something on the table to check it, because we know all those values are correct. So let's see if it works. Which term do you want to use? Which figure number? 7. 4 or 7? Either one? Let's do 4 this time. So I'm going to look at figure 4, and I know the answer should be 7. Okay, so this is how we're going to check it. Will you always be able to check it? Sometimes if I give you a table and I say find all this information, yeah. But other times I might just give you just a pattern, and you would need to figure out which term is it. So I'm looking for f of 4 because it's my 4th term equals a negative 6 times 4 plus 31. Okay. What is negative 6 times 4? Hello? One of you knows? What is it? Okay, good. Negative 24 plus 31. What is that? What's negative 24 plus 31? 6? 4? What's 31 minus 24? 7. Is that what my term should have been? Is that what my answer should have been? Is that true? Yes. Is the 4th term 7? Yes. Yes, I think. Can you find the 13th term for me? Because you know what it should be. Can you prove it using the table? Or using the formula? You just did it. You got negative 47 as the 13th term, and that's what you found yesterday when you subtracted it, didn't you? But wasn't this like a lot faster? Okay, can you do the same for pattern 2? Can you find that explicit formula for me? I'm not going to do it for you. I'll check it, but can you find the explicit formula for pattern number 2, please? The other arithmetic one. Okay, have we found this one yet? Not yet? Did we? Yes. You got it? Okay, what's my pattern rule for pattern 2? Add 4, so that's my common difference. Is that going to be M or B? M. Okay, what is my zero term for this one? 1. Good. Because since I was adding 4 each time to go backwards, I'm going to subtract 4. And 5 minus 4 is 1. So, is this what we have? Yes. Like that? Yes. Okay, can you find the value when n equals 73? Can you just find that for me? Can you find the 73rd term in this sequence? Find the 73rd term in this sequence. Okay, we have f of 73 equals... Is that what you got? Yes? You got it right? Okay. Okay, I'm going to do one last one. We have 4 minutes. I'm going to write one up on the whiteboard that is unrelated to anything that we've done. And I want you to find that, I'll tell you to find the explicit formula and which number to find, okay?